Hello everyone, I hope you all are fine and you are going through my videos understanding the concepts of physics. Dear students, we have completed our chapter 5, that is surface tension, and now today we are going to start our chapter number 6, that is thermal expansion. Students, as its name is suggesting, expansion means it will expand. So it can expand in length also, it can expand in case of surface area also, or it can expand in terms of volume also. Okay, but the other word associated with expansion is thermal, and thermal is directly related to temperature. That means with rise in temperature there are some type of expansions which we called thermal expansion. So you can see the definition of thermal expansion at the top of the board, that the expansion of almost all solids on increasing temperature is called as thermal expansion. Students, thermal expansion is of three types, that is linear, superficial means related to area, and volumetric expansion means related to volume. So let us study one by one these three types of expansions. First is linear expansion. If the length of the object gets increased with rise in temperature, then this expansion is known as linear expansion. Means if length is increasing of any object with increase in temperature, means temperature you are increasing, then this type of expansion will be called as linear expansion. And students, for expression we have taken that let original length of object is L and length after expansion is L dash. Let us suppose the original length was 5 centimeter, and when you increase the temperature, obviously the length will increase. So it will become, let us suppose, 7 centimeter. So what is the change? What is the increase in length? That is L dash minus L. Okay, 7 minus 5 equal to 2 centimeter. So this is just example. Okay, so if L is the original length, L dash is the length after expansion. So what will be the increase in length? That is L dash minus L. Okay, so students, it depends upon two factors. Means कितनी length increase होगी, ये कितने factors पे depend करता है? Two factors पे. First factor, it is directly proportional to original length. Original length ज़्यादा होगी तो आपकी increase in length will also be more. And it depends upon change in temperature. Means how much temperature change is there. पहले आपका टेम्परेचर 5 डिग्री था, फिर आपने उसको 10 किया कि 15 किया कि 20 किया. Means how much temperature is changed. So that is change in temperature. So L dash minus L is directly proportional to delta T. First step में आपने लिखा L dash minus L is directly proportional to L. In second step, L dash minus L is directly proportional to delta T. Combining these both, L dash minus L is directly proportional to L delta T. When this proportionality sign is removed, students, one constant will come. So you can see I have put here equal to alpha delta T. L dash minus L equal to alpha delta T. This is the sign of symbol of alpha. Okay, so you can see on the top now that L dash is equal to L plus alpha L delta T. That L I have brought on the other side, so its sign will change, it will become plus. L I can take common, 1 plus alpha delta T. So in all these three steps you can see alpha is here, and alpha is known as coefficient of linear expansion. Okay, so now next is our superficial expansion. Students, what I told you, what we call alpha. Alpha is known as coefficient of linear expansion. It is very important because whenever we will find relation between alpha, beta and gamma, we will use these relations. Okay, next is superficial expansion and volumetric expansion. Both are exactly same as first one. So superficial expansion I'm explaining once again, and volumetric expansion you will do by your own. Okay, so let us start. Superficial expansion. Students, if area of object, now you are increasing temperature. In first, length was increased, in second, now we are increasing area. So if area of object gets increased with rise in temperature, then this expansion is called as superficial expansion. Okay, so for this we are taking, let S is the original surface area and S dash is the area after expansion, and increase in area, what will be then? S dash minus S. As we have done in first case, it depends upon two factors. S dash upon S is directly proportional to S. S dash minus S is directly proportional to delta T. Combining both and following the same steps, at last you will get S dash is equal to S1 plus beta delta T. And here this beta is called as coefficient of superficial expansion. Okay students, and our last part is now volumetric expansion. Students, volumetric expansion means that if with rise in temperature, the volume of the object gets increased. If volume of the object gets increased, then this is known as volumetric expansion. So now it's your work that you have to follow same steps, and at last you will get one equation, that is V dash is equal to V1 plus gamma delta T. Okay, and here this gamma is called as coefficient of volumetric expansion. Coefficient of volumetric expansion. So students, this is all about my today's topic, that is thermal expansion. So once again I am recapitulating the topics we have studied, that the thermal expansion means the expansion of solids with rise in temperature, and it is of three types: linear expansion, superficial expansion, volumetric expansion, and expression for these are L dash is equal to L plus 1 L dash is equal to L into 1 plus alpha delta T, S dash is equal to S into 1 plus beta delta T, and V dash is equal to V into 1 plus gamma delta T, where this alpha, beta, gamma, these are the coefficient of expansion. Alpha is coefficient of linear expansion, beta is coefficient of superficial expansion, and gamma is the coefficient of volumetric expansion. So I hope you understood my today's topic. So please do write in your notebook also, and revise it. For any query you are free to ask me. This is enough for today. Thank you. Have a good day.